Welcome back to the Deep Dive, everybody. Today, we're going to look into the work and legacy of Neweton da Costa. He was a really influential figure in 20th century logic and philosophy, and we sadly lost him this year.
Yeah, it was really a big loss.
Yeah.
He's probably most famous for developing paraconsistent logic. And so that's what we're going to be unpacking in this deep dive.
Okay, so let's start with the basics here. So in classical logic, the kind of logic that we kind of intuitively use most of the time, there's this very strict rule that if you find even a single contradiction in a system, like something can be true and false at the same time, then, well, anything can logically follow from that.
Right.
Which is kind of this domino effect of nonsense, right?
Yeah.
And da Costa was basically like, hold on a second. What if we could handle these contradictions without the whole thing falling apart?
Yeah.
So how does that even work?
Well, so paraconsistent logic is like this really interesting way for logical systems to handle these contradictions, without everything becoming meaningless. For example, think about a self-driving car.
Okay.
And it's receiving conflicting data from two different sensors.
Oh, okay.
So one sensor says there's an obstacle ahead, but another sensor is saying the road is clear. Now, in classical logic, this contradiction would really throw things off. It could even cause the system to just completely freeze up. But with paraconsistent logic, the system could actually keep on reasoning.
Wow.
It could, for example, prioritize the data from the sensor that's known to be more reliable.
Okay.
Or it could even flag that inconsistency for a human to look at later.
That makes a lot of sense. So it's like a way more nuanced way of dealing with the real world, basically.
Exactly, yeah. And it goes way beyond just self-driving cars.
Yeah.
Da Costa's work has really had a big impact in many different fields. When you think about philosophy of science, mathematics, physics, even economics, law, computing, AI. I mean, that's a pretty wide reach for one person's ideas.
That's huge, yeah. And it wasn't just this abstract idea. Right?
Yeah, no, definitely.
He also came up with something called the theory of quasi-truth.
That's right. So a lot of real-world situations and even our best scientific theories, they aren't always perfectly consistent or complete.
Right.
So Da Costa's idea of quasi-truth says that a theory can still be useful, even if it's not perfectly true in every single detail.
Okay.
It can still hold what he called a degree of near truth.
Okay.
And be super valuable for making predictions and just generally understanding the world. Think of it kind of like a map,
Oh, okay.
A map is not a perfect representation of reality.
Right.
But it's still really helpful for navigation.
Yeah, that's a great analogy. So getting back to Da Costa and his paraconsistent logic, his work actually sparked a whole movement, right?
Yeah, it really did. And it actually led to the rise of something called the Brazilian School of Paraconsistent Logic, which really shows his impact on this field globally.
Wow, that's pretty cool. But so what was the original kind of motivation for developing this kind of logic in the first place? A logic that could actually embrace contradictions.
Well, one big push was to deal with paradoxes in set theory. Have you ever heard of Russell's paradox?
Yeah, I think so. Remind me what that is again.
Yeah, so it's this kind of mind-bending logical puzzle that shows how contradictions can arise even in the most basic ideas of set theory.
Oh, right. Like those problems that kind of threaten the foundations of math.
Exactly, yeah. And there was also this desire to formalize something called dialectical logic, which is this philosophical idea that contradiction can actually drive understanding forward. And then on top of that, think about those apparent contradictions in quantum mechanics.
Right.
Like Bohr's complementarity principle, where light can seem to act like both a wave and a particle.
Yeah.
Paraconsistent logic offered a potential way to deal with these weird situations without just dismissing them as nonsensical.
Okay, so that's the theoretical side of things, but this also had real-world applications, right?
Absolutely. I mean, think about building AI systems or those big knowledge databases that pull info from all sorts of sources online.
Yeah.
Those sources often disagree with each other.
Right.
So paraconsistent logic gives you the tools to reason with that kind of conflicting information in a way that makes sense. It prevents the whole system from just breaking down because of one little inconsistency.
Wow. So essentially what Da Costa did was he completely revolutionized the way we think about contradictions.
Yeah.
Right? Instead of seeing them as these things that lead to logical chaos, paraconsistent logic lets systems remain useful and informative even when inconsistencies pop up.
Right. It's a totally different way of thinking about logic compared to that all-or-nothing approach of classical logic.
Right. So it's not like if there's one contradiction, the whole thing falls apart. Yeah.
Exactly. It's much more flexible.
Yeah.
And a really good example of this is how paraconsistent logic deals with the principle of explosion, which is a core idea in classical logic.
All right.
In classical logic, remember, one contradiction makes everything trivial.
Right.
Paraconsistent logic rejects that idea completely. It lets us explore and learn from inconsistent information.
So how does that change how we think about truth in those systems?
Well, it's a big shift. Classical logic depends heavily on the idea that something can't be both true and false at the same time.
Right.
But paraconsistent logics often modify or don't fully embrace some of those core inference rules that classical logic relies on.
Yeah.
For example, disjunctive syllogism, which is this rule that says if you know A or B is true and A is false, then B must be true.
Okay.
Paraconsistent logic says not so fast. And then da Costa's idea of quasi-truth takes us even further. It suggests that even our best scientific models might have some inherent incompleteness or inconsistencies.
And that's okay.
Yeah, and that's okay.
Wow. So, to wrap things up here, I think the big takeaway is that da Costa's work gave us these incredible tools to deal with the messiness and complexity of the real world,
Yeah, I think that's right.
where things are rarely black and white. So as you go about your day, just think for a second. In this world that's just overflowing with complex and often seemingly contradictory information, this ability to think clearly and make decisions even when things don't perfectly align, that's something that da Costa really pioneered.
Yeah.
And it could profoundly change how we approach knowledge and understanding in so many different areas. It really makes you think about what truth even means, doesn't it?
It really does. It changes everything.
That's all the time we have for today. We'll see you next time on The Deep Dive.
See you then.